Welcome to day 27 of our STL Mastery course. Today we are diving into one of the most elegant and powerful features of modern C++, the Lambda functions. We will learn what lambdas are, why they are crucial in STL algorithms, how to write and customize them using capture lists, and see them in action through several practical examples. By the end, we will be writing expressive, clean code that integrates lambdas with standard algorithms like a pro. So what exactly is a lambda function? In C++, a lambda is simply an anonymous function, meaning a function with no name. It's defined inline, right where you need it, often in a single line of code. Lambdas were introduced in C++11 and have since become indispensable in functional style programming with STL. They are especially useful when working with algorithms that need small pieces of logic passed as parameters. Let's take a closer look at the syntax of a lambda function. A lambda is structured as capture list followed by parameter list, then optionally the return type, and finally the function body. The capture list allows the lambda to access external variables. Parameters define what inputs the lambda accepts. Most of the time you can omit the return type as it can be inferred. It's concise and incredibly flexible. Here's a simple yet powerful use case, sorting a vector in descending order. Using the sort algorithm with lambda, we pass a custom comparator right to the call. Notice how the lambda takes two integers, compares them using greater than, and the vector gets sorted in descending order, all without creating a separate function. This is clean, compact, and highly readable. Capture list is what gives lambdas access to variables from the surrounding scope. Empty brackets mean you capture nothing. Square bracket equals captures everything by value, and while square bracket ampersand captures everything by reference. You can also be specific and capture individual variables either by value or reference. This mechanism provides precise control over what data your lambda uses and how. Lambdas shine brightest when combined with STL algorithms. Functions like sort, countif, foundif, findif, and removeif all accept a function object, and lambdas make it easy to provide that on the spot. Need a custom condition or operation? Just write a lambda right inside the algorithm call. It keeps your code concise, localized, and expressive. Let's count the even numbers in a vector. The countif algorithm takes a range and a condition. We pass a lambda that returns true when a number is divisible by 2. This one-liner replaces what would normally be a for loop and an if condition. It's efficient and readable, the hallmark of good modern C++. By default, variables captured by value are immutable inside lambdas. You can read them but not modify them. However, with the mutable keyword, you can change these values inside the lambda. Here's an example where a counter is captured by value but still incremented using mutable. But be careful with mutable captures. They modify the copy inside the lambda, not the original variable. Lambdas are just function objects, so you can store them in variable and use them like any other function. This is especially useful when you want to reuse the same logic multiple times. For example, here we assign a greater than comparator lambda to a variable and then use it with sort. It makes your code even cleaner and avoids repetition. Let's apply lambdas in a slightly more advanced example. Sorting a vector of structs. Suppose you have a list of students with names and marks. Using a lambda, you can sort them based on their marks or any other membered variable. This shows the true power of lambdas when combined with user-defined types and STL. Now it's your turn to get hands-on. Try sorting a vector of strings by their lengths using a lambda. Then use countif to count how many elements in a vector are greater than 50. Finally, remove all even numbers from a vector using removeif with a lambda. These exercises will help reinforce everything you have learned today. To summarize, lambda functions are compact, anonymous functions you can define inline. They work beautifully with STL algorithms and let you write expressive logic right where it's needed. With captured list, parameter lists, and mutable support, you can handle a wide variety of cases, all with clean modern syntax. Lambdas are not just a syntax sugar, they are an essential part of modern C++. Here's your assignment for today. First, sort a vector of pairs based on the second element using a lambda. Next, partition a vector into events and odds, again using a lambda to define the condition. Finally, capture a threshold value and use it in a lambda to filter out elements below it. This task will really cement your understanding of lambda functions in real case.